Today's lecture is about types of AI. This lecture is on types of AI. Artificial intelligence can be categorized in several ways depending on the perspective and level of abstraction. Based on perspective and level of abstraction, artificial intelligence can be categorized in several ways. So now, based on capabilities, what are the categories? Based on capabilities. So narrow AI, which is weak AI, or narrow AI. The definition is that AI that is designed to perform a narrow or specific task. It cannot generalize beyond its predefined functions. Examples are speech recognition, then recommendation systems, speech recognition, Siri, Alexa, recommendation systems, Netflix, Amazon recommendations, then facial recognition systems, then spam filters in email. So speech recognition, recommendation systems, facial recognition systems, spam filters in email, these are the examples of narrow or weak AI, and this work on based on the capabilities. This is one of the classification where the classification is based on what is the AI system is capable of. Then comes the general AI or the strong AI. Okay, general AI or the strong AI. The definition is that this AI that can understand, learn, and apply intelligence across a wide range of tasks. Similar to human intelligence. This is kind of similar to human intelligence because human intelligence is also applying intelligence across a wide range of tasks. This type of AI does not yet exist. Examples are hypothetical AI, since it does not exist, that can perform any intellectual task that a human can do. Then super AI, which is artificial super intelligence. So definition is that AI that surpasses human intelligence. It surpasses human intelligence in all aspects, including creativity, problem solving, and decision making. This is purely theoretical and does not yet exist. Examples of super intelligent AI would theoretically be capable of solving complex problems that humans cannot even comprehend. Now the classification based on functionality. Classification is reactive machines. These AIs can only react to specific inputs. And situations. They do not store data or past experiences. They do not store data or past experiences for future use. So do not store data for past experiences for future use. Now the examples include like Deep Blue, which is IBM's chess playing computer, AlphaGo, which is Google DeepMind's Go playing AI. Then there is classification based on limited memory. These AIs can use past experiences and data, for a short time, but they do not have long-term memory. Okay. The examples are self-driving cars that use data from recent driving experiences to improve their navigation in real time. Then there is theory of mind. Definition is a hypothetical AI that can understand emotions, beliefs and mental states of humans. That can understand emotions, beliefs and mental states of humans or other entities. Other entities is also there. It would need to understand the intentions and emotions of others. Example is this type of AI does not yet exist but is a goal for more advanced AI system. Self-aware AI. So this is the most advanced form of AI. You can say this is the most advanced form of AI, which would have its own consciousness. Okay, self-awareness and emotions. This is purely theoretical and does not exist. Examples: a fully self-aware AI would be similar to a human in terms of emotional intelligence and self-awareness. Now classification based on learning techniques. So supervised learning is there. Supervised learning, AI learns from labeled data by using input output pairs. So input is given and the corresponding output is given. So several such examples are given. From that the AI learns. So what will be is if some new input is given, what will be its output. The system makes predictions and gets feedback on whether feedback is there on whether they are correct, whether predictions are correct or not. Based on that feedback they improve. Examples are image classification, identifying objects in images, spam detection in emails, then unsupervised learning. Here the AI learns from unlabeled data. It is learning from unlabeled data. Discovering patterns, it is discovering the patterns or structures without explicit feedback. Explicit feedback is not there. Examples are clustering algorithms, that is grouping, then anomaly detection, identifying fraudulent transactions. Reinforcement learning. Reinforcement learning, AI learns through trial and error. Here the AI learns through trial and error by interacting with the environment, and receiving rewards or penalties. So it receives rewards or penalties and it learns by trial and error by interacting with the environment. Example is robotics, then game playing AIs, like that. The self-supervised learning, this is very important. This AI learns from unlabeled data by generating labels automatically. Labels are generated automatically. This is a growing area, particularly in natural language processing. It finds a lot of application. So it is generating the labels automatically. So like large language models, vision models that predict parts of an image from other parts. Transfer learning. Transfer learning, here AI takes knowledge learned in one domain and applies it to a different but related domain. So it takes knowledge from one domain and applies to a different but unrelated domain. Examples like natural language processing models pre-trained on large text corpora and fine-tuned for specific tasks. They are pre-trained on large text corpora and then fine-tuned for specific tasks. For example, sentiment analysis, like that. Now classification based on applications. We have natural language processing. Here AI that process, understands and generates human language. So process, understands, process, understands and generates. Examples are chatbots, GPT-4, Google Bard, machine translation like Google Translate. Now then computer vision, AI that interprets and understands visual information. So examples are image recognition like facial recognition, object detection in autonomous vehicle systems. Then we have robotics. In robotics, we have the definition is AI is used to create autonomous systems that can interact with the physical world. Examples are industrial robots used in manufacturing. Then humanoid robots, almost like humans. Expert systems, AI systems that mimic that decision making ability of a human expert, somebody who is an expert, knows a lot about a particular field, like medical diagnostic systems. Here very famous is the IBM Watson for healthcare. Then financial market analysis. Speak recognition and generation, AI systems that can recognize and generate spoken language. Examples of voice assistants. Now, based on architectures and models, rule-based AI, AI that operates on predefined rules and logic. Expert systems that use a set of if-then rules to make decisions. Then machine learning, a subset of AI that focuses on systems that can learn from data. Decision trees, then neural networks. Then deep learning, a subset of machine learning that uses neural networks with many layers. These are called deep neural networks. Examples are convolutional neural networks for image recognition, then recurrent neural networks for sequential data like time series or language. Then generative AI that generates new content such as text, images, music or code based on patterns learned from training data. Examples are GPT-4 for text generation, DALL-E for image generation. Now emerging AI paradigms. Neuromorphic computing, AI that mimics the architecture and functionality of the human brain using artificial neurons and synapses. It mimics the architecture and functionality of the human brain using artificial neurons and synapses. Examples are brain-inspired chips and hardware such as IBM's True North chip. Then quantum AI that leverages quantum computing principles to process information in ways that classical computers cannot. This is still a research area, but it holds a promise for solving complex optimization and simulation problems faster than classical AI. Then explainable AI systems designed to be interpretable and transparent, making their decision making understandable, making their decision making process understandable. So examples are interpretable models used in healthcare here in healthcare this is very important to explain diagnosis or treatment recommendations. This overview provided an overview, this lecture, of different types and classifications of AI based on various criteria. And as AI continues to evolve, new categories and types may emerge. Thank you very much.